Okay, let's discuss the series diode configuration. So if you remember in our past discussion, there are three commonly used semiconductor diode. So the first one is the silicon, second one is the germanium, the third one is the GaAs. So if you remember, the silicon has a voltage drop of 0.7, germanium has 0.3, and the GaAs has a 1.2 volts. So in this discussion, we will discuss this, how the diode operates in a series. So if you remember, diode acts as an electronic switch. So you can turn it on. You can also turn it off, depending on the polarity of the current. So for example, if the polarity of the voltage is in this direction, meaning may current pa rin. So if E is equal to the voltage drop of the silicon, which is 0.7, equal or greater, so this circuit will act as in short circuit. Mo-on siya, no? So it will act as a let's just redraw. So this will be mo siyang supply, no? It's 0.7 volts. So this is E. So mo drop siya og 0.7. So likewise, if we reverse the polarity, this is plus and minus. We reverse the polarity. So this is minus, this is plus. Like that. So if we reverse the polarity, so meaning the current will flow in this direction. So as you can see, dire forward bias ang atuang diode. Dire, so since baliktad man siya, so meaning atong diode is at reverse bias. So if you remember in our topic, if ang diode is at reverse bias, mo off siya. So if mo off siya, it will not allow current to flow. So open circuit siya lang, no? Yung equivalent. So this is ang ID na to is equal to 0. No current flow. But ang VD na to dre, so since this is open circuit, equal is sa E. No? E. Wala may current flow. So meaning mura kagatester dere o gra. So meaning kani ang voltage drop po dere, this is equal to 0. VR is equal to 0. So since silicon mo siya, so how about if this is ideal? So in an ideal diode, so in an ideal diode, so doon na ito balik, ha. So if you say ideals, meaning perfect, no? In a perfect diode. Kani since this is silicon, so na siya voltage drop nga 0.7. So in an ideal diode, imong BD is equal to 0. So if naka-forward bias siya, ang iyang voltage drop is equal to 0, no? BD is equal to 0. If naka-forward bias siya. So likewise sa silicon diode, if naka-forward bias siya, nasa drop nga balik 0.7. So kani sa ideal lang siya. So this is meaning more on theory. So it does not exist it's just gigamit na to ni ideal diode in order to just to understand the diode in a simple manner, no? Simplicity niya ba? Ma-understand niya. So, ideal, mura naman siya o switch. Either on or it's either off. In this case, na-on man na itong diode. So, likewise, kung naka-reverse polarity siya, so, if naka-reverse bias siya, so, reverse, so since the direction sa current is the man, so meaning, atong diode is naka-reverse bias. So, naka-open circuit dire, closed circuit, naka-open. So, since closed nun so, current flow, naka-on. So, makalahos ang current from this direction. Tama na, no? But dire, as you can see, ang atong diode is naka-open circuit man. So, as you can see, gap, no? Dili makalahos ang current from this point to this point. So, meaning, naka-off ni. Off ni. Naka-on ang diode ani. So, in this case, we are using the ring apart silicon. You can also use germanium and gas. So, if it is germanium, 1.3 ni. If it is gas, this is 1.2. No? Really, ideal diode man So, it is just a representation, no? Just an ideal diode. So, let's have an example. So, let's have an example. Okay, let's have an example. For the series diode configuration, determine VD. So, this is VD, by the way. VD, BR, so this is BR, and ID. So, if you remember Kirchhoff law in our load line analysis topic, no? So, since this is series, so this is from Kirchhoff voltage law, no? Plus, minus, and minus. So, this is E minus VD minus BR equal to 0. So, alternate lang ang sign. Well, so, may pangitao na to ni BD. So, since, as you can see, this is silicon, automatic na ni BD is equal to 0.7 volts, no? Nakakay 5 points. So, what's next? BR. So, in our case, BR. So, solve na itong BR, no? So, BR is equal to, bali na ito speakers, E minus BD. So, therefore, BR is equal to, ilang E? E is equal to 8 volts. So, this is 8 minus 0.7. So, this is, so therefore, this is 7.3 volts. So, unit is very, very important. What else? ID. So, as you can see, muna yung current ID. So, since naka-series naman, series mo yung diode o resistor, so meaning, ang current sa diode o ang current sa resistor are the same. So, since series naman. So, therefore, since ID is equal to R, IR, no? And, niagi po siya R. So, kabulutan sa BR, kabulutan sa resistance. So, you can use the Ohm's law. VR divided by R. Well, therefore, this is 7.3 divided by 2.2 kilo ohms. Kilo na, so that is 2.2 kilo ohms is just equal to, so yan na siya sa 2 times 0.2 times 10 to the 3, which is equal to 2,200 ohms. Sa kilo ohms man. So, use your calculator. Divided by so, ano siya, no? Ano yung answer? 3.31. So, as you can see, times 10 to the negative 3 man. So, this is 3.32 milliamps. Okay, times 10 to the negative 3. So, this is our ID. No? So you have now BD, you have now VR, and there. So what if i-reverse na tong polarity sa E? So, reverse polarity. So, this is minus plus 8 volts. So, hindi mo na siyang plus, minus, plus minus. So, this is 2.2. This is R, this is BD. The same, sulbon nga po na ito si BD, VR, and ID. So, like in our example, BD is equal to, pila mo ng BD. By the way, kung reverse polarity na niya siya, so you will draw the equivalent circuit. So since the current is in this direction, so meaning kani, so niya state on or off. So naka-off siya, reverse bias man. So if naka-off siya, equivalent circuit niya is open circuit. Naka-open siya. No? So this is R, 2.2 kilohms. So muna ito ang BD. Open circuit siya. So, muna ito ang VR. So, what is, una na ito ID. What is ID now? Equal to, say current. Sige ito, basta reverse bias. Putol mo na siya. Therefore, if reverse bias, so ang diode na to is naka-off. No current can flow. So, pila man ang ID. If no current can flow. Equal to 0. Very good. 0. How about VR? So, VR, di ba ang formula? VR is equal to IR times R. Pila man ang IR. So, since ID is equal to IR, which is equal to 0 amps, so therefore, this is 0 times R. ER is also equal to 0. So, kung 0 ni, ilang BD? So, kuhanin mo ni minus, minus, minus. So, 8 minus BD minus VR equal to 0. So, BD is equal to, balance because 8 minus VR. Ilan man ang VR? VR is equal to 0. Oh, 0 na, no? So, BD is equal to 8 volts. Muna yung may tabo. Okay, let's have another example. As you can see, this is a very weird circuit, no? So, wala supply. So, ang supply na ito is 0.5. So, if makakita kag bubble like this one, this is a supply. This is a ground, no? Meaning, this is, kanis siya, connected niya sa negative. Connected niya siya sa ground. So, meaning, if you redraw this one, kanis supply man eh. Ano na siya? This is 0.5 volts as minus. Muna yung equivalent circuit. So, kung meaning ka ni, connected siya sa negative, ani? Wala. Connected siya, wala. No? So, this is 1.2 kilo ohms. So, this is VR. This is BD. 3 ang ID. So, this circuit is equivalent to this circuit. No? This 5. Muna yung plus 5? Muna eh. Ground. Kani siya dari connected siya, ana. Muna siya ground. So, in this example, we are going to calculate the same, no? ID, BD, and as well as VR. So, we'll use, this is a silicon diode. So what is our supply voltage? Supply na to is 0.5 volts. And we are using a silicon diode which is, kung yung voltage drop, 0.7 volts. Meaning, kani 0.7 volts, mo na yung requirements, minimum requirements para muon ang ato ang silicon diode. No? 0.7. So, 0.7 is the minimum requirements in order for the diode to turn on. So, since ang atong supply voltage is 0.5, what will happen to the diode? Kulangan niyang voltage. So, meaning, mo sa siya, ma-reverse. Ma-off, no? Off siya. Once ito basta off. So, meaning, kung off siya, open circuit ang ato ang silicon diode. Open circuit siya. No? Why? Because the supply is 0.5 volts, and since this is silicon, minimum requirements sa silicon is 0.7. Kung germanium pa ni, okay mo on pa ni siya. But since this is silicon, off siya. So what is now ID? Lagyan pang ganyan, no? ID is equal to 0, VR is equal to 0, BD is equal to 0.5 volts. Simple. Okay, let's have another example. As you can see, duha na kabuk diode, no? But as you can see, ang usa tawag ani, this is LED, light emitting diode. So this is just a diode, but siga siya. Color siya yung siga is red. So sa silicon, voltage drop niya is 0.7. Sa red nga LED, yung voltage drop is equal to 1.8 volts. So I'll just tagalan ta mo og makita niyo siya sa chapter 1. Chapter 1, no? Figure 1.8. Dito list of tables sa LED, no? And its equivalent voltage drop. Dito lain-lain color and its equivalent voltage drop. And I also send you a link, no? For the introduction of LED. Wala man ako na-introduce ko. So let's continue. So determine the output voltage and the diode current. So, kung si duha naman siya, which is naka-series ang diode, duha ka diode as well as the resistor. Kani, muna yung output voltage man with respect to the ground. So, as you can see, bubble mo siya, muna yung supply, and then ground. Kung mo na siyang i-redraw, ano na siya? Redraw na to, sketch. No. No. So this is 12 volts. This is 680 ohms. Which is one yung Diode. So meaning kung makuha kag tester, dari ang plus, dari ang minus. So LED, nana siya ay aro-aro duwakbok yung schematic. Maniya ang equivalent circuit. So they are both forward bias. No? So 12 volts na eh. So musang silicon. So let's name this one BD1 na lang. And this is BD2 plus minus. KVL KVL. So current niya is dropping on. So therefore this is 12 volts minus 0.7 man eh. No? Plus minus 1.8 minus kani about this one, B out equal to 0. So therefore bali na to ni sa pikas. So B out is equal to 12 minus 0.7 1.8 equal to 0. Pila mo na? So this is user calculator mo na ang 9.5. This is 9.5 volts. How about ang current? Current na to. So, ang current diri is equal to ID magipangita. Diri, no? So, since naka-series naman na yung diode ang resistor, so therefore, ang ID na to is equal to IR, which is na natay voltage, no? Use Ohm's law, VO divided by the resistor ng R. No? Pero na kay VO, 9.5 divided by 680. So use your calculator. This is 9.5 divided 680. Oh. Sa 13.97 milliamps. 13.97 milliamps. So I'll post another video for more examples. So, muna niya ang last. So, goodbye.